Are you struggling to run inference on your hardware? Do you end up finding yourself wishing your hardware was more capable, more powerful, and your models were able to do the tasks that you need them to do? Well, if that's a problem you've encountered and you don't want to throw more compute power at the issue, then you might just want to hear what we have to say next. Today, we're going to be speaking to Positron AI, who believe that memory might be the key to creating more powerful AI inference potential.
We don't believe that there's a problem to solve on the training side. We think GPUs are the right architecture for that part of the workload. In terms of when you get to the inference side, we want to make that as simple, as inexpensive, as performant, and as low power as possible. We've actually been shipping our first gen Atlas servers for almost 18 months now, and it's most comparable to a Hopper class GPU, again, for the inference side of things. And we're developing our own ASIC, so our own custom silicon that will tape out later this year, and then we'll be launching that into our second generation Titan servers that will come out in 2027.
I always like to ask, what was the technology? We're all standing on the shoulders of giants, especially here in the tech world, from the humble beginnings of, the simple circuit all the way up to the complex things we have today. What would you say is your direct predecessor? What are you replacing in the market? What do you think you bring to the table that makes you the next step in the evolutionary chain?
Sure. Well, I think it's, the age-old challenge of, are you going to use a general purpose technology to solve a problem, or are you going to start to build purpose-built solutions for a given problem? And we, from day one, when we started Positron, we said, we know that transformer model inference, like large language models as an example, is very much a memory-bound challenge, not a compute-bound challenge. And so just throwing more and more flops at the problem is not solving the challenge. And so what we decided is we're going to flip the memory to compute ratio on its head and have significantly more direct attached memory for every one of our products, and therefore get much better performance at much lower cost and much lower power consumption than a general purpose solution like a GPU or even a TPU or other solutions on the market.
I'm going to bring my layman understanding of what you just said into this. Of course, I'm not an AI engineer, just a humble embedded engineer, but I'd like to ask you this question. So with something like ChatGPT, I'm assuming based on what you said, your AI model is going to be a bit more contextually aware than something like ChatGPT. It will be a bit more like, it would have a bit more of a memory and understanding of let's say, the data that's being fed into it.
That's right. And context lengths, which is the amount of data that you're putting into the model in order to get a response, is growing almost exponentially, because we're starting to use these AI tools for things like software programming. And so the context length ends up being the existing program, and then you're going to iterate on that program. And so you need to have millions and millions of tokens for context length in order to achieve really performant code generation. That's just one example. Another good example of why you need a lot of memory is on video generation. So today, all of these video generators that are AI based give you like a 10-second limit on output. And that's because they're memory bound. And so once we throw as much, we'll be able to throw up to 9.3 terabytes of memory per server at the problem. And in that case, you'll actually be able to generate much longer videos with very little time to wait for your video.
So tell me a bit about your vision, the Positronic Brain, and what does that mean to anyone that may want to go into AI engineering or maybe deploy their own AI systems?
Yeah, so we actually think that ultimately the largest frontier large language models or transformer models more broadly, and the foundational models that are out on the open source community should run on Positron. I think, again, training, fine-tuning these models should be done on a GPU architecture, but then once you're ready to actually run that model in production, that's where we want to provide the absolute best-in-class, purpose-built solution.
I'm an aspiring AI engineer, for example, and I come to Positron AI. What am I really getting from you? Am I getting the hardware? Am I getting the software? Am I getting the full stack? Do I need to do anything? Is it all going to be handled by you? If I do need to do something, what resources do I have to learn how to do so?
Yeah, so one of our, when I said earlier in the conversation that we want to remove complexity, that's one of the pieces of complexity we want to remove. The short answer to your question is we provide the entire system. So from the chip that we're designing to, how it fits into a Titan server with our second generation product that will come out next year, all the way through the software layer, we've developed it all, and it's literally a plug and play solution for running AI inference workloads. In terms of the AI developer, if you're already making OpenAI compatible calls today, we will look exactly like that when you move that workload from probably a GPU today over to Positron. So there's actually no real software work to be done by the AI engineer. And really, our ultimate vision as a company has been since day one, we want to be able to make, going out to Hugging Face and grabbing, from the very large repository of open source models, make it a drag and drop experience onto our hardware. And that's the vision that we're realizing and we'll have available to everyone to use in time for Titan.
Well, had a look through your website earlier today, and I've noticed, of course, you have the Atlas, which is shipping now, but I also noticed you have the Titan and the Asimov. So tell me a bit about those products and what they will bring to the market.
Yeah, so one of the things that we did very differently than most chip companies is we actually launched a product within 18 months of incorporating the business. That's almost unheard of in the hardware space. And the way we were able to do that is by leveraging an FPGA. Just think of it as a programmable chip. And so our engineers programmed this FPGA to be fully optimized for transformer model inference. And we were able to get production grade servers into paying customers' hands within a year and a half of starting the company. Our second generation product, the server is called Titan. The underlying chip that we're designing is called Asimov. And that chip is leveraging the programming that we did inside the FPGA, but it will be that on steroids in terms of the amount of memory and memory bandwidth that we're going to be able to throw at the inference challenge.
So Titan is the whole stack, the server stack, and then Asimov is going to be your latest kind of chip that's gonna power, I'm guessing, a new stack or maybe a new Titan.
That's correct. Yes, and so Titan is the server, Asimov is the chip. The entire server of Titan only consumes 4,000 watts in operation, and we can literally provide better than 3x the performance of like a 400 server Rock/NVIDIA system. With one of our Titan servers, we could actually provide 3x the performance on a model like K2 Kimi.
With the Asimov chip, is there going to be any possibility of me, let's say, I want to make my own stack for one reason or another, be it security, be it, just for the sake of practice, for the sake of learning? How compatible would that chip be with other technologies? Would it be easy for me to use that in other technologies, or is it something that's locked into your Atlas system?
Yeah, so in terms of running large language models, again, we wanted to make that a seamless experience for anyone who has used an OpenAI compatible endpoint. We look the same in terms of how you interface and how you send large language model requests into the server. We actually are building a PyTorch flow as well. And so if customers want to run other workloads, we will enable that. That will come with our second generation, not so much with the first generation Atlas servers that we've been shipping for 18 months now.
Do you have any other secrets to share with us here at ipX? Do you got anything else on the horizons?
Yeah, I wouldn't say it's so much a secret as I would say, engineering excellence. One of the things that Positron has done very differently than the currently available hardware for running these inference workloads is we're getting over 90% of our available memory bandwidth in practice. And so if you go and fire up a GPU alternative and run a workload, you're going to get maybe 25, 30% of the available memory bandwidth will actually be utilized during that inference workload. And that's a challenge that we set to solve from day one, and we're already achieving over 90% of our available memory bandwidth.
Okay, that sounds exciting. So let's say I'm going to conventions, I'm traveling across the world. Where can I find Positron AI? Are you going to be at Embedded World, CES? Let us have an idea of where we can find you.
So we do attend and speak at a number of events. I know one in particular is called the Accelerated Compute Conference, which is coming up in March in Times Square. And we will certainly have a booth presence at SC26, Supercomputing Conference 26. So we'll have a booth there. And then we do appear at a number of conferences this year and speak and are part of panels. We just got back from the Middle East where we did the Web Summit in Doha. And so we will continue to add to the number of conferences that we attend and have a strong presence at.
Let's say I'm starting my business now and I want to utilize Positron AI. Where can I speak to you? Where can I find you? Where can I get my hands on the Titan when it comes out, or on the Atlas currently?
Yeah, you can use Atlas today. And so there's a few different ways to do that. One is we have a number of hosted servers that we give potential customers or developers who want to try our system. We give them an API key. Like I said before, it's an OpenAI compatible key, and then they log into the system and they have dedicated access to one of our servers to kind of kick the tires and try before they buy if they wish. As I said earlier, also by the end of April, we will have one of the 4 US hyperscalers will be live with a 50 rack deployment of our hardware. And that's another place that people will be able to touch and feel the performance, really understand what it is that Positron AI is bringing to the market. So that will be available very soon. We're also lighting up an AI Neo Cloud over in Europe that will go live in Q2 as well. And so there's going to be a number of different options for customers to try the system and then decide either they want to continue to use through a cloud service provider of choice, or they actually want to buy and deploy hardware on premise. Really, the best way just to get a hold of us is just come to Positron.ai, and then you can click the contact form if you want us to reach out to you, or you just reach out to me directly at Cameron@Positron.ai.